All right, what is up, guys? Mr. Rushka here. I know that this worksheet I gave for homework is really hard. I know this stuff is really hard, okay? It's very normal to find it really hard. I found it really hard when I was in pre-cal, okay? So what I'm just going to try to do here is give you guys some tips and tricks, right? I can't give you like a magic formula method for doing these, right? This is not the quadratic equation. Right, I can't just give you a little simple fix, but I can give you little tips and tricks for stuff you can try when you get stuck on these, okay? Okay? Number one tip I have, try, okay? Because partial credit, right, that saved us on the test. That saved us on the last test, okay? Partial credit is a good thing. And it can get your grade higher than you might think, okay? So yeah, let's dive into this first one because this first one has an example of something you guys should look out for, okay? That second thing is a sine or cosine multiplied by a tangent or a cotangent. And if you see that, what you want to do is change your tangent slash cotangent to a fraction. Okay? All right? You want to change your tangent or cotangent to a fraction. Remember, if you look on your formula sheet here, tangent and cotangent, right, they can be changed into fractions. These are the 8 big hitters for 5-1 and 5-2. Okay? Tan and cotangent can be changed into a fraction with those identities or those equations. Okay? So this is so cosine x plus sine x tan x becomes cosine x plus sine x times sine x over cosine x. Okay? Sine x, right, that's the same as sine x over 1. So this becomes cosine x plus sine squared x over cosine x. Okay? Sine times sine. Sine x times sine x is sine squared of x, okay? And then at this point, I can show you guys another tip, okay? Notice our answer here, secant x, has one term, okay? So if the answer, I'll say the right, if the right side of the equation has less terms than the left side, then what you want to do, so this is another trick you can use, change the left side to fractions and combine the terms. Change left side to fractions and combine. Okay? So that's going to be another popular method. It's going to be another popular one, okay? Right, so I have two terms here, a cosine and a sine squared over cosine. I need to end up with just one term, just a secant. So I probably need to combine these two, right? Now cosine x, right? Cosine is the same as cosine over 1, right? So let's get a common denominator. My common denominator is usually just going to be, for these trig problems, right? I'm not just dealing with like numbers. I'm dealing with trig symbols, okay? My common denominator is just going to be my two denominators multiplied together. Okay, so it's going to be cosine. So I need to multiply this guy on the right on the left by cosine x over cosine x. Okay, that's going to give me cosine squared x plus sine squared x all over cosine x. Okay, this brings me to my next point. Look for, number 4. Terrible handwriting, sorry. look for and recognize, I don't know what the name of them is, but recognize these, these three. Look for those. Look for them everywhere. 1 sine squared plus cosine squared, or 1 plus cotangent squared, or 1 plus tangent squared, okay? Look for and recognize these guys. Cosine squared plus sine squared, or 1 plus tangent squared, or 1 plus cotangent squared. Those are going to pop up all the time, okay? Use your identities when you see them, okay? All right, this is hard stuff, guys, but these are problems, okay? Maybe I shouldn't say this as a teacher, but these are problems that American high school math teachers made so that you guys could solve them. Use the tool. The teachers want you to use the tools that they taught you in class, okay? You're just going to do these same, 4 things over and over again, basically. I know it's tough. It is very difficult, okay? So recognize that cosine squared plus sine squared equals 1. Change that to a 1 on top. 1 over cosine x, right? Use your reciprocal identities, okay? Okay. Changing stuff to fractions is often a good idea. Comes secant x. There we go. So that's our answer, okay? All right. Let me switch colors for the next one. Okay. Right here, cosecant x minus sine x all over sine x cosecant x, okay? Okay, so what I'm going to do is I'm going to go to number 2. The same principle applies for number 2. It applies to cosecant and secant as well. Okay? If you see a sine multiplied by a cosecant, you also want to start changing cosecant x to a fraction. Okay? If you look on your identity sheet, and we've also talked about this all of chapter 4, cosecant is just 1 over sine. Okay? So I'm going to go back to my identity sheet. I'm going to go back over here. Okay, so sine x cosecant x. So I'm going to write this down. So the left side's going to become, if I change that cosecant x to a 1 over sine, I'm going to get sine x times 1 over sine x. Okay? Again, this sine x right here is technically a sine x over 1. So when you multiply these two fractions together, the sine x's cancel out. You're left with just a cosecant minus sine of x, okay? Boom, that's our answer, okay? What's nice about these, since they're proofs, is if you get them right, you can be automatically 100% certain that you got the answer to the problem, okay? That's what's nice about them. So a lot of you guys struggled with this one. It was a simple one-stepper, okay? I really want you guys to recognize stuff like this, okay? When you multiply a sine by a tangent or a sine by a cosecant, all right? When you see two functions multiplied together by that, you're oftentimes gonna want to change the tangent or cosecant to a fraction, okay? All right, let's do number 3, okay? Okay, let's look at my list here. Which little trick does number 3 do I use for number 3? Let's think about this. Number 3. It's going to be number 3, okay? The right side of my equation here has 1 term. The left side of my equation has 2 terms. So I'm going to need to combine these two, okay? So let's change this tangent beta. Beta is this little B-looking symbol here. It's a Greek letter. It's just a letter, okay? It's just a variable like any other variable. It's just fancy. So let's change that tangent beta to a tangent beta over 1. And then my common denominator is just going to be my 2 denominators multiplied together. So tangent beta. So I got to multiply the top and bottom of this fraction by tangent beta over tangent beta. Okay, so the left side of that equation, let me use a different color real quick, is going to become 1 over tangent beta plus tangent squared of beta all over tangent of beta. Okay, and then just like fractions in elementary school, we can just add straight across the top. All right, and again, look, now if you got stuck here, you might get stuck here. Again, you're probably just going to use one of these 4 little tricks. I'm going to use trick number 4. Look for and recognize these 3 things. Okay? These 3 expressions. What do I have here? I have a 1 plus tangent squared. Okay? Looking at my identity sheet, I see that that becomes a secant squared. Okay? So I'm looking at this line here. Oh, man. So dusty and dry. Dang it. Okay. So I can change the top of this guy to secant squared of beta. And it's still all over tangent of beta. Okay. Let's see here. Oh, I'm done. Okay, cool. Awesome. Sweet. I might simplify that one a little more myself, but that's all the problem asked for, okay? So we're done. So we literally just used 2 of these tricks up here. We used trick number 3 and we used trick number 4, okay? So these problems are tough. You have to be really creative, but a lot of the times you really only use one of these 4 little tricks, okay? All right. Which trick am I going to use here? What do you think? All right, well, the right side of the equation only has 1 term. The left side has 2 terms, so I probably need to combine these fractions, okay? That's using trick number 3. They love that one, okay? All right. So I'm coming back here. My common denominator is going to be the 2 denominators multiplied together, okay? So I got to multiply the guy on the left by 1 plus sine theta over 1 plus sine theta. Okay, and I want to say something here. Actually, I'll wait, okay? And then I got to multiply the guy on the right by cosine theta over cosine theta, top and bottom, okay? So that guy on the left on top, let me do this in a different color. The top of this fraction, when I expand that out, that'll become 1 plus 2 sine theta plus sine squared theta, okay? And I just did that by foiling. So first, outer, inner, last. Just like I did in Algebra 1, okay? And then I'm going to say it now, okay? A lot of the times you don't want to expand. You do not want to expand the denominator. Okay? A lot of the time you don't want to do that. Only do it if you get super stuck and have no freaking clue what to do. Okay? A lot of the time it's just going to be easier for you guys. Don't just leave the denominator as is. Don't distribute this cosine. Don't do it. Don't do it. It's a trap. Anyone ever seen Return of the Jedi? Okay. And then over here, the second fraction becomes a plus cosine squared theta all over cosine theta plus, cosine theta times 1 plus sine theta. I told you guys not to expand that, okay? There you go. So once I have a common denominator, I can just add straight across the top. So I get 1 plus 2 sine theta plus sine squared of theta plus cosine squared of theta. On the bottom, I have cosine theta times 1 plus sine theta. All right. Good. So we use trick number 3. Trick number 4, right? Look for and recognize one of these 3 identities. Okay? Recognize that sine squared plus cosine squared here, okay? So then that gives me 2 plus 2 sine theta all over cosine theta times 1 plus sine theta, okay? Okay, notice how these 2 guys right here are so similar. They almost cancel. We can almost cancel them, right? We have a 1 plus, this is technically 1 plus 1 sine theta here. On the top, we have a 2 plus 2 sine theta, okay? So another trick you're going to want to do is factor. Factor sometimes. Factor when you see a match. Okay, they give you a lot of low-hanging fruit with number 5 here, okay? So I almost see a match. I see there's 2 2s right here, so I can factor out a 2. Am I out of space almost? Okay. I can factor out a 2, rewrite that as 2 times 1 plus sine theta all over cosine theta times 1 plus sine theta, right? These guys will cancel. I get 2 over cosine theta, and then dividing by cosine is the same as multiplying by secant, okay? So rely on these guys. Change stuff to fractions, okay? Good stuff. Okay, number 5. What do we notice? You should notice, again, the right side of the equation, number 3 here, the right side of the equation has less terms than the left side, right? The right side has 1 term, the left side has 2 terms. So we've got to fix something here, okay? We've got to change that secant to 1/, we got to change those to fractions. So secant becomes 1 over cosine, tangent becomes sine over cosine. All right. Then we already have a common denominator. So the left side became this pink stuff here. The common denominator lets us add straight across the top. Okay. All right, so that gets us here. Okay. We're really close. Okay. So a 6th trick is multiply by the denominator of the answer, okay? Okay, so looking over here, the answer has a 1 minus sine y in it. I have a cosine y, okay? I'm so close. So you know what I'm just going to do? I'm just going to say screw it and just force this fraction to have a 1 minus sine y in the bottom. And I'm going to do that by multiplying the top and bottom of this fraction, and these have parentheses on them, by that 1 minus sine y I see in the denominator there, okay? The top of this fraction, when I FOIL this out, first, outer, inner, last, that's going to become 1 minus sine squared of y. And the bottom, right, the bottom I'm just going to let chill there. I'm just going to let that chill. Do not expand it out, okay? Don't expand the denominator unless you're absolutely stuck, have no idea what else to do, okay? I'm going to add something to trick number 4. I'm going to add something to trick number 4. You also want to look for, oh gosh, come on. You also want to look for and recognize 1 minus sine squared and 1 minus cosine squared. Also recognize those two, okay? If you modify this trig identity right here, you get 1 minus cosine squared of theta equals sine squared of theta. And you can also get 1 minus sine squared of theta equals cosine squared of theta. Just by, I can subtract over the sine squared or subtract over the cosine squared. So recognize those as well. Okay, look for and recognize these 5 guys. Use your identities, okay? So 1 minus sine squared is cosine squared. All right. And then this might be kind of tricky for some people, but in the top here, I have a squared, something squared over that thing. So like in algebra 2, if you saw like u squared over u, you would know that that simplifies to u to the 1. The same thing happens here. This cosine cancels with the square on top, and I get cosine y over 1 minus sine y. And I'm done, okay? All right. Number 6. Number 6 got me at first. Okay, number 6 was kind of a toughie. So how do I want to explain this one? Number 6, okay, you have one term in top, one term on the left. Sorry, you have one term on the left and one term on the right, okay? So we can't use trick number 3. We don't really have trick number 2. We don't have trick number 4. We almost have trick number 4, but this is a 1 minus tan squared. It only works for 1 plus tan squared, okay? I want to show you guys something, though. I'm going to copy down. I'm going to use something that's in the spirit of rules number, or tricks number 2 and 4. It's in the spirit of those two. You're probably stumped where the heck you begin here. So just try, when you see a tangent or a cotangent, just try changing it, this guy right here, into a fraction, okay? So the left side becomes cosine squared minus sine squared all over 1 minus sine squared over cosine squared. Now, if you look at this, look what we almost have. We almost have a 1 minus sine squared. There's just a pesky little cosine squared x hanging out in the bottom of this guy here, okay? So what I'm going to do is I'm going to multiply to get rid of that cosine squared. I'm going to multiply the top and bottom of this fraction by cosine squared over cosine squared, okay? Oh, whoops. I have to put the parentheses here. So distribute on the top. You'll get, do you want to distribute that? No, you don't. Okay, don't distribute on top. Sometimes you don't always want to distribute. Okay? So don't always distribute. Okay? Maybe hold off for a sec before you do that. Let's write our next step down. So the top stays like this. And the bottom becomes that. Okay, when I distribute that term out, right, this cosine squared cancels with the denominator here, just leaves me with the sine squared. Okay? Then look. These two are the same. This is why I didn't want you to distribute out the cosine squared. These two are the same. You can just cancel them out. You get cosine squared of x. Boom, done. Okay? That's our answer. Okay? All right here. Okay? Trick number 3 applies. Okay? The right side of my equation has one term. The left side has two terms. So let's combine these. Okay? My common denominator is going to be the product of the two denominators. Okay? So I'll multiply. Let me scratch that 7 out. Let me multiply the guy on the fraction on the left by sine x over sine x. Okay? And I'll multiply the fraction on the right by cosine x plus 1. Okay? So expanding all that out, right, I get a sine squared x over sine x times cosine x plus 1. And I'm going to leave that there. And add in, when I expand the top here, I just FOIL, just like in algebra. I get cosine squared x minus 1 all over that same denominator. Sine x times cosine x minus plus 1. And again, it's often a good idea not to expand the denominator out. Just leave it like that. Don't distribute the sign yet, okay? So adding those terms across the top, I get sine squared of x plus cosine squared of x minus 1 all over my denominator. Okay. Same trick, right? I'm using these same tricks, guys. These same 5 all over and over again. A little bit of 6 going on. Okay. Okay, but recognize these 5, okay? I've got a cosine squared plus sine squared here. So that's going to become a 1 minus 1 on top over my denominator. Oh, sorry, let me write that better. One minus 1 is 0, so I get 0 over sine x times cosine x plus 1. And 0 over anything is just 0. Okay, so that's my answer. Done. Okay. So these are tough, but I am using these same 5 or 6 tricks over and over again. Okay. Number 8 down here. Okay. For me, I first recognize that this is 1, okay, and this is secant squared. Okay. That's just trick number 4. Recognize these 5 guys. Okay, and use your identity sheet. Okay. So the left side here, and I'll do this in blue, becomes a 1 plus cotangent squared of theta over secant squared of theta. Okay. And then again, 1 plus cotangent squared. I can recognize that. That becomes a cosecant squared of theta. Okay. Okay, so I need to be left with cotangent squared. Okay. Cotangent squared of theta equals cosine squared of theta over sine squared of theta, okay? So I'm really close. I'm really close to this guy, okay? Yeah, I'll make this its own trick. Trick number 7. Sometimes try changing stuff into fractions, especially if it's a secant or cosecant. Hey, Mom. So especially you want to try this if you're doing cosecant, secant, cotangent, or tangent. Teachers love having you change those four into fractions. So the guy on top becomes a 1 over sine squared. Right? The guy in the bottom becomes a 1 over cosine squared of theta. Right? And dividing a thing by a fraction, right? That's the same. So dividing by a fraction is the same as multiplying by its reciprocal. So the reciprocal of 1 over cosine squared is cosine squared over 1, which is cosine squared theta over sine squared theta, which is cotangent squared of theta. There you go. There's my answer, okay? So let's go on to the next page. Again, we use those same 7 tricks, okay? Right here, okay? Sine times cotangent. They love that. Number 2. I think number 2 is the easiest trick to recognize and use, okay? If you see a sine multiplied by a cotangent, change the cotangent to a fraction. So this becomes sine x times cosine of x over sine x. Right, and this factor on the left here, right, that's the same as sine x over 1. Okay. When you multiply these two fractions together, those two signs cancel out, just like they did in algebra. And I'm left with a cosine x. Okay, there you go. Simplifies to that. Secant x over cosecant x, okay? Use trick number 7. Use trick number 7. These same 7 tricks you're just going to do over and over again. So change secant to 1 over cosine of x. Change cosecant to 1 over sine of x. Okay? So dividing 1 over cosine by 1 over sine is the same as multiplying by sine over 1, right? And that becomes sine x over cosine x, which is tangent of x. There you go. Right here, recognize trick number 4. Trick number 4, recognize these. Recognize my guys, my dudes. Okay. So this becomes a cosine squared in top. Okay. And then, right, u squared over u is just u. So cosine squared over cosine is just cosine. Okay, there you go. All right. Number 4 here. They give you low-hanging fruit. Notice there's 2 terms, and part of these 2 terms match, right? When you see that, you want to factor, okay? I think I wrote that up here. Factor number 5. Factor when you see a match, okay? I think we're having a little bit of trouble factoring this out. Okay, so what you want to do is you want to treat this sine t as if it was just like one variable, basically. Basically, treat it like a variable. So if you had u minus u times cosine squared of t, and I told you to factor out the common denominator, or the greatest common factor, you would see this matching u in each term, and you would factor that out, right? You'd do u times 1 minus cosine squared t, right? I factored out a u, so I did u divided by u, became 1. U cosine squared t divided by u became just cosine squared of t. Okay? Do that same thing, right? But it's just sine. Treat sine like it's one variable. So I'm going to pull a sine t out of that first term. That first term becomes a 1, right? Because sine t divided by itself, divided by sine t equals 1. And then sine t times cosine squared of t divided by sine t is just going to leave me with a cosine squared of t. Okay? Recognize this, trick number 4. Okay? Sine t times sine squared of t. That 1 minus cosine squared becomes a sine squared. That's from my identities worksheet, okay? And just like u times u squared equals u cubed, sine times sine squared equals sine cubed. Okay. Number 5, I'm going to use trick number 2. It's really only 6 tricks, honestly. Number 1's not really a trick. It's just a very good piece of advice. But number 2, right? I've got a sine multiplied by a tangent, okay? So change that tangent into a fraction. Right, and that sine x is the same as sine x over 1. So you get cosine x plus sine squared of x over cosine x, okay? Again, use that trick number 3. We don't have equations down there, but we still do have change stuff into fractions and combine. Teachers love having you do that. If you're stuck on where to go next, and you have multiple terms, just try changing them into fractions with the same denominator and add them, okay? So this cosine x here is the same as cosine x over 1. Right, my common denominator is just going to be the two denominators multiplied together. So my common denominator is going to be cosine x. So I have cosine squared of x over cosine x plus sine squared of x over cosine x. Okay, adding straight across the top, I get a cosine squared plus a sine squared over cosine. Okay, trick number 4, right? I'm using the same 6 or 7 tricks. I'm doing the same 6 or 7 things every time on these. Cosine squared plus sine squared equals 1. And then that using what's called my reciprocal identities. Right here. Okay? Can change that 1 over cosine into a secant of x. Okay? Right here, number 6, 2 terms. You see a little match here, right? There's a sine x in both my terms. So use trick number 5. Sorry, guys, let me change colors. I bet this might be kind of hard to follow, which problem is which. Okay, so I'm going to factor this just as if it were u cubed plus u times cosine squared of x, right? If I told you to pull a u out, you would do u times u squared plus cosine squared of x, okay? So just treat sine like it's a variable. So I'm going to pull a sine x out, and that'll leave me with sine squared of x plus cosine squared of x, okay? Trick number 4 that I wrote up there, okay? Let's recognize that this is 1, okay? Look for the match. Just look for the identity. So this becomes sine x times 1, or just sine x. Okay, so that's my answer there. Good stuff. All right, up here. So what do I want to tell you? What do I want to tell you? Okay, you get stuck on this, you're completely lost on what to do. Try number 7. Just try changing stuff into fractions, right? Okay, if we don't really have a match, we can't do 5 or 4. Can't do 3 really. We only have 1 term. Number 2, we don't see an instance of number 2, unfortunately. Okay. Try 7, okay? So this is going to become, I'm going to change those cosecants into 1 over sines. Okay. And then, trying to figure out the best way to explain how to recognize this, right? But I almost have a 1 minus sine squared up top here, right? I almost have that. I have a 1 over x minus sine of x, okay? So what I'm going to do is I'm going to multiply the top and bottom of this fraction by sine of x, okay? So I'm thinking to myself, how can I turn the top of this fraction into a 1 minus sine squared? Well, if I multiply by sine on both terms, it turns into that, okay? So if I multiply by that, distribute my sine x, it's going to become 1. Sine x times 1 over sine is just 1. Sine x times sine of x is sine squared of x. Okay? And then 1 over sine times sine is just 1. Okay? Trick number 4, recognize the top there. That's one of my identities. That gives me cosine squared of x. Boom. All right. Good. Okay. And then number 8, right, we can just use trick number 3. Use trick number 3. Just try combining. Change the fractions into common denominators and combine. Okay. So I'm going to scratch out that 8 real quick. Yeah, I'm going to change this to blue. Okay. So the fraction on the left, right, my common denominator is going to be the two denominators multiplied together. Again, don't expand your denominator. Only expand that if you, have to, okay? I'm not saying you're never, ever going to do it, but, just do it as a last resort, okay? So multiply by 1 plus sine x over 1 plus sine x. Okay, top and bottom. This guy over here, I'm going to multiply by cosine x on top and bottom. Okay. So that left term becomes, if I distribute the sign, I get 1 plus sine squared of x. All over, I'm going to leave the denominator as is. I'm just going to let my guy chill. Top becomes cosine squared of x. Okay. And then at this point, right, I can just add straight across the top. Okay, trick number 4, recognize that this is 1. So this becomes a 1 plus 1 in the top, or just 2. Okay. And then I did this problem yesterday. What does it change into next? No, it changes into something. How many of them will get this far in the video? No, I'm kidding. I'm kidding. Oh, I did something wrong. So sine x, right? When I distribute this sine x to this 1 right here, I wrote down that that's 1. That's not 1. Sine x times 1 is sine. Sorry about that. I was like, there we go. So I should have sine x plus 1. Sorry about that. I did this problem yesterday, and it was way easier. I should have sine x plus 1. This still becomes a 1 here. And sine x plus 1 over 1 plus sine, those cancel. I'm left with 1 over cosine of x, which is just secant of x, okay? All right, guys, please bear with me again. The purpose of this video, I needed to make an answer key anyway. I really wanted you guys to see that on these problems, I'm really just doing the same 5 or 6 things over and over, okay? Recognize and see and use, okay? Execute, okay? Thank you, guys. Okay, please just keep trying, okay? If anything else, number 1, try. Get your partial credit, okay? You take care, guys.